In the early 1970s, the world's largest car company claimed clean air laws were unrealistic, unfair, and technically impossible. Engines, they argued, simply could not meet the new standards without sacrificing everything drivers loved. Then, a much smaller Japanese manufacturer quietly disagreed. Instead of lobbying politicians or adding expensive hardware, one engineer chose a more dangerous path, challenging the fundamentals of combustion itself. His solution looked strange, sounded impractical, and violated what Detroit considered common sense. Yet, it worked. What followed was not just an engineering success, but a public embarrassment that exposed how deeply innovation and corporate power can drift apart. Smog chokes the global streets. Picture this. It is the late 1960s, and the air in the world's most advanced cities isn't just hazy, it is actively trying to kill you. In Tokyo, at the Ushigome-Yanagicho intersection, residents are collapsing with high concentrations of lead in their blood, simply because they live too close to the traffic. In Los Angeles, the smog is so thick it burns your eyes and blots out the sun. This wasn't just an inconvenience, it was a full-blown public health emergency that demanded a radical solution. Enter Senator Edmund Muskie of Maine. In 1970, he spearheaded a piece of legislation that would change the automotive world forever, the Clean Air Act. This law was built on a terrifyingly bold concept known as technology forcing. Muskie and his colleagues didn't care if the technology to clean up cars actually existed yet. Their stance was that public health required clean air, and it was up to the engineers to figure out the impossible to meet that requirement. The mandate was staggering. The law demanded a 90% reduction in carbon monoxide and hydrocarbon emissions by the 1975 model year. To put that in perspective, cars were spewing out nearly 90 grams of carbon monoxide per mile, and the government told them they had to get that number down to barely 3 grams in just 5 years. The response from Detroit was immediate and hostile. The Big Three, General Motors, Ford, and Chrysler, didn't see this as a challenge. They saw it as a death sentence. Instead of rushing to the drawing board, they rushed to their lawyers. Chrysler went so far as to run advertisements, claiming there was no scientific evidence that automotive exhaust actually posed a threat to human health. The titans of American industry decided that the problem wasn't the pollution, but the law itself. Detroit's expensive Band-Aid solution. Detroit eventually realized that no amount of lobbying or legal maneuvering could make the Muskie Act disappear. Faced with a mandate they could not defeat, the Big Three panicked. Instead of tearing down the internal combustion engine and redesigning it to be inherently cleaner, they decided to treat the symptom rather than the disease. Their solution was the catalytic converter, a device championed by General Motors for the 1975 model year. The concept was essentially an exhaust after-treatment system. As the dirty gases left the engine, they traveled through a canister filled with a ceramic honeycomb or pellets coated in precious metals like platinum and palladium. These metals acted as a catalyst, triggering a chemical reaction that oxidized the deadly carbon monoxide and unburned hydrocarbons, converting them into carbon dioxide and water. It was a chemical incinerator for pollutants attached to the end of the tailpipe. However, this additive solution created a catastrophic domino effect for performance. The primary enemy of the catalytic converter was lead. For decades, lead had been added to gasoline to boost octane levels and prevent engine knocking. But lead coats and poisons the platinum inside a converter, rendering the expensive device useless within minutes. This forced a nationwide transition to unleaded fuel, which at the time was scarce and offered much lower octane ratings than the leaded fuel it replaced. To prevent engines from destroying themselves on this lower quality fuel, American engineers had to drastically lower the compression ratios of their engines. The result was the malaise era of the automobile. Massive V8 engines that once produced serious horsepower were suddenly choked down to embarrassing output levels, often struggling to make even 150 horsepower from 5 liters of displacement. Fuel economy dropped and the cars became sluggish and unresponsive. This was a classic case of lazy engineering. General Motors didn't fix the combustion process. They simply slapped a fragile, expensive filter onto a dirty engine. They solved the emissions problem by strangling the engine's efficiency, creating a compromise that satisfied the regulators but punished the driver. Honda's impossible lean burn gamble. While Detroit was mobilizing its legal teams and resigning itself to the expensive band-aid of catalytic converters, a very different scene was unfolding across the Pacific. Soichiro Honda, a man who had only recently transitioned from making motorcycles to cars, viewed the Clean Air Act not as a regulatory death sentence, but as a strategic opening. He believed that if an engine was dirty, the engineer's job was to fix the combustion, not filter the exhaust. To solve this, Honda established the Air Pollution Control Research Laboratory, or AP Lab, in Tokyo. This was not a titan of industry throwing money at a problem. It started with just 10 members and grew to a modest team of 30 engineers. They were true underdogs, lacking even the basic instrumentation to measure nitrogen oxides or hydrocarbons. Before they could fix the pollution, they effectively had to invent the equipment to see it, cobbling together their own testing procedures with gas chromatographs. The team spent years running down dead ends. They investigated rotary engines and gas turbines. They tested thermal reactors, which were essentially afterburners that cooked the exhaust gases. But thermal reactors required a fuel-heavy, rich mixture to function, which destroyed fuel economy. It was a wasteful approach that didn't sit right with Honda's philosophy of efficiency. Guided by the theoretical insights of Professor Tsuyoshi Asanuma, the team eventually zeroed in on the holy grail of combustion, lean burn. The logic was elegant in its simplicity. The chemical ideal for burning gasoline is roughly 14 parts air to 1 part fuel. If you could push that ratio higher, flooding the cylinder with excess air, the chemistry shifts in your favor. The extra oxygen ensures that almost all the carbon monoxide is oxidized, and the abundance of air absorbs heat, keeping temperatures low enough to prevent the formation of nitrogen oxides. The problem was that lean burn was theoretically perfect, but practically impossible. Igniting a lean mixture is like trying to light a campfire where the logs are spaced 2 feet apart. The fuel molecules are so diluted by the air that the spark plug often fails to start a chain reaction. The result is a misfire. The engine shakes, loses power, and ironically pumps raw, unburned fuel out of the tailpipe. The 3-valve mechanical hack. Here is where the engineering gets absolutely brilliant. To solve the impossible physics of lean burn, Honda didn't invent a new chemical. They invented a mechanical hack. They called it the Compound Vortex Controlled Combustion System, or CVCC. And while the name sounds like something out of a sci-fi novel, the concept was actually an ingenious adaptation of a pre-chamber design found in old diesel engines, repurposed for a gasoline world. The secret sauce of the CVCC was that it broke the rules of standard engine architecture. In 1971, almost every car engine had 2 valves per cylinder, one to let the air and fuel in, and one to let the exhaust out. Honda added a 3rd valve. This wasn't for performance, it was for precision. They created a tiny auxiliary intake valve that fed into a separate, specialized compartment called the pre-chamber. Think of this pre-chamber as a thimble-sized room located right next to the spark plug. This little room was separated from the main cylinder by a perforated metal plate with a small nozzle known as the torch opening. This simple piece of geometry changed everything. Let's walk through the combustion cycle to see why this was such a game changer. It starts with the suction stroke. When the piston moves down, the main intake valve opens and fills the big cylinder with an extremely lean air-fuel mixture. So lean that a normal spark plug would just stare at it and do nothing. But at the exact same time, that tiny 3rd valve opens and fills the thimble-sized pre-chamber with a very rich, fuel-heavy mixture. So, you have a stratified charge, a small pocket of highly flammable gas sitting right next to the spark plug, and a large cavern of lean gas sitting in the main cylinder. Next comes the compression stroke. As the piston drives upward, it squeezes everything. A little bit of that rich mixture gets pushed through the torch opening, creating a bridge between the 2 zones. Then, ignition. The spark plug fires inside the pre-chamber. Because that mixture is rich, it lights instantly and reliably every single time. But here is the trick. Instead of just pushing the piston down, that explosion looks for an escape route. It finds the torch opening. A jet of flame shoots out of that hole like a blowtorch. It blasts into the main cylinder with incredible thermal energy. This isn't a weak little spark trying to light a wet log. This is a flamethrower. That concentrated jet of fire is powerful enough to ignite the lean mixture in the main chamber completely and evenly. The result was combustion perfection. The excess air in the main chamber ensured that all the carbon monoxide was oxidized into harmless carbon dioxide. And because the flame spread relatively slowly and evenly, the peak temperature inside the cylinder never got hot enough to form significant amounts of nitrogen oxides. Honda had effectively tricked the physics. They achieved a clean burn not by filtering the smoke, but by perfecting the fire. They did it all without a single catalytic converter. Big business versus engineering pride. By December 1972, Honda had officially proved to the EPA that the CVCC worked. But back in Detroit, the executives at General Motors weren't impressed. They looked at Honda's tiny Civics and saw irrelevant novelties, not serious engineering. The attitude was summed up perfectly by Richard Gerstenberg, the chairman and CEO of General Motors. When asked about the Japanese breakthrough, he famously scoffed, stating that while he had looked at the design, it might work on some little toy motorcycle engine, but he saw no potential for it on one of their GM car engines. This was a massive miscalculation. Gerstenberg was a finance man, a bean counter who saw the world in terms of volume and profit margins. Soichiro Honda was an engineer who saw the world in terms of mechanical truth. To him, physics was universal. If a combustion principle worked on a small cylinder, it would work on a big one. He didn't just take Gerstenberg's comment as a business dismissal, he took it as a personal insult to his honor as an engineer. Soichiro Honda didn't hold a press conference to complain. Instead, he initiated one of the pettiest and most brilliant engineering flexes in history. He ordered his staff to go out and buy the most American car they could find, a 1973 Chevrolet Impala. This wasn't a car, it was a land yacht. It weighed nearly 5,000 pounds and was powered by a massive 350 cubic inch V8 engine, the heart of the American auto industry. It was the exact vehicle Gerstenberg claimed the technology couldn't handle. Honda then did something unheard of. He had this massive steel beast air freighted across the Pacific Ocean to his research facility in Japan. Imagine the logistics of flying a 2.5-ton sedan halfway around the world just to win an argument. Once it arrived, his engineers stripped the top end of the engine. They didn't touch the transmission, they didn't strip out the air conditioning, and they didn't lighten the chassis. They simply cast new custom cylinder heads with the CVCC 3-valve system, bolted them onto the American V8, and prepared to send it back to the EPA. Honda was going to beat GM at their own game, using their own car. Honda fixes General Motors' mess. Once the massive Chevrolet Impala touched down in Japan, the Honda engineers didn't strip it down to a shell to cheat the physics. They knew that for this point to land, the car had to remain a true American cruiser. They kept the heavy 3-speed automatic transmission. They kept the power steering pump. They even kept the air conditioning compressor. The only thing they changed was the heart of the beast. They designed and cast brand new cylinder heads specifically for the Chevy 350 block, retrofitting their 3-valve CVCC system onto the most common engine in America. With the surgery complete, the Impala was loaded back onto a plane and flown to Ann Arbor, Michigan, where it was handed over to the Environmental Protection Agency for official verification. This was the moment of truth. The EPA subjected the car to the rigorous federal test procedure, simulating a full 5,000-pound vehicle inertia. The results, published as Report Number 7413, were nothing short of a revelation. The modified Impala didn't just scrape by the regulations, it crushed them. The car met the stringent 1975 statutory standards for hydrocarbons and carbon monoxide without a catalytic converter. It did it without an air pump. It did it without an exhaust gas recirculation system. It achieved what Detroit claimed was impossible, using nothing but smarter airflow and better combustion timing. But the real humiliation for General Motors was found in the fuel economy numbers. The EPA report noted that the CVCC-equipped Impala actually delivered better gas mileage than the stock version produced by GM. The drivability was rated as excellent, with none of the hesitation or stalling that plagued the choked-down American engines of the era. Honda had taken General Motors' flagship product, applied their own toy technology to it, and made it cleaner, more efficient, and better to drive than the original manufacturers were capable of doing themselves. The argument was effectively over. Honda had proven that the problem wasn't the size of the engine, but the imagination of the engineers. 50 engineers versus 50 lawyers. Following the successful testing of the Impala, Soichiro Honda delivered what might be the most devastating verbal takedown in industrial history. In a 1974 interview with Playboy magazine, he was asked to explain the fundamental difference between how his small Japanese company and the American giants were approaching the new emissions laws. His answer was simple and surgical. He told the reporter that when Congress passes new emission standards, Honda hires 50 more engineers, but General Motors hires 50 more lawyers. This was not just a witty quip to sell magazines. It was a precise diagnosis of a massive cultural divide. General Motors viewed the Clean Air Act as a threat to their existence, a piece of drastic medicine that needed to be fought in court, delayed by lobbyists, and watered down by politicians. They poured millions of dollars into a defensive strategy, treating the regulation as a legal problem rather than a mechanical one. Their goal was to protect their sunk costs and maintain the status quo for as long as possible. Honda, on the other hand, viewed the exact same legislation as a starting line. Soichiro Honda realized that he could never beat General Motors in a spending war or a production war. But if the rules of the game were changed so that everyone had to start over from scratch, the playing field was suddenly leveled. He didn't see the regulation as a burden. He saw it as a creative constraint that demanded a better product. This difference in mindset explains why the wealthiest corporation on Earth was outmaneuvered by a company that had only been building cars for a decade. GM used their massive resources to build a wall around their old technology, hiring armies of attorneys to argue that clean air was impossible. Honda used their limited resources to build a bridge to the new technology, hiring engineers to prove that it was possible. One side was fighting for the past, while the other was building for the future, proving that in the world of technology, agility and attitude often matter far more than the size of the budget. The Civic conquers the crisis. The Impala experiment was a masterclass in psychological warfare, a middle finger to the automotive establishment delivered in the form of a cylinder head. But a prototype, no matter how brilliant, is just a science experiment until you can put it in a driveway. The real revolution wasn't the modified Chevy, it was the mass-produced machine that followed it. That machine was the 1975 Honda Civic CVCC, and it arrived with a level of timing that was almost suspicious in its perfection. Just as Honda was finalizing the production of their new clean engine, the geopolitical world fell apart. The 1973 oil crisis sent shockwaves through the American economy. The Organization of Arab Petroleum Exporting Countries proclaimed an oil embargo, and practically overnight, the price of fuel skyrocketed. For the first time in history, Americans were waiting in lines for hours just to get a few gallons of gas. The era of the fuel-thirsty 5,000-pound V8 was instantly over. Suddenly, horsepower didn't matter. The only number that mattered was miles per gallon. Into this perfect storm drove the Honda Civic. It was small, it was light, and thanks to the CVCC engine, it was the most fuel-efficient car in America. The EPA testing revealed that the Civic could achieve 28 miles per gallon in the city and a staggering 42 miles per gallon on the highway. In a world where domestic behemoths were struggling to hit 12, the Civic looked like a miracle of engineering. But the Civic had another secret weapon that arguably mattered even more than the mileage. It was the only new car that wasn't picky about its dinner. Remember that the Detroit solution, the catalytic converter, was extremely fragile. It required unleaded fuel, which was often more expensive and harder to find at gas stations in the mid-70s. If you put leaded gas in a new Ford or Chevy, you would destroy the emission system in minutes. The Civic, however, had no catalytic converter to ruin. It cleaned its emissions inside the fire of the combustion chamber, which meant it didn't care what kind of fuel you put in the tank. It could run on the new unleaded fuel, the old leaded fuel, or anything in between. While American car owners were frantically hunting for the specific pumps that wouldn't void their warranties, Honda owners could pull into any station, fill up with whatever was cheapest and available, and drive away. This combination of extreme efficiency and absolute convenience was unbeatable. Honda's sales in the United States didn't just grow, they exploded, more than doubling between 1974 and 1975. The Civic rapidly displaced the Volkswagen Beetle as the default small car for the American driver. It proved that the weird combustion trick wasn't just a way to satisfy a regulator, it was a better way to build a car. The company that Detroit had dismissed as a toy maker was now the market leader in the only metric that counted. Giants pay for the toy. Honda's victory with the Impala did more than just bruise some egos in Detroit. It destroyed their primary legal defense. For years, the Big Three had argued that meeting the Clean Air Act standards was technologically impossible. But once as a small motorcycle company from Japan proved it could be done with a clever mechanical design, that argument evaporated. The result was a wave of capitulation in the form of licensing agreements. Toyota was the first to cross the line, signing a deal in 1972 to use the CVCC patents for their own engines. Soon after, the floodgates opened. Ford, Chrysler, and Isuzu all lined up to pay for the privilege of using the technology. There is a profound irony here. The same industry giants that had dismissed Honda as a maker of toy engines were now writing checks to that very toy maker to save their own fleets. It was a complete shift in the power dynamics of the global automotive industry. However, no technology reigns supreme forever. The CVCC system was a mechanical masterpiece, but by the 1980s, it began to hit the limits of what purely mechanical engineering could achieve. The regulations continued to tighten, specifically the 1981 amendments, which demanded even lower levels of nitrogen oxides. To keep the carbureted CVCC engine compliant, Honda engineers had to add layer upon layer of complexity. If you pop the hood of a mid-80s Honda Accord or Prelude, you will see the physical manifestation of this struggle. Mechanics call it the vacuum hose spaghetti. The engine bay is a terrifying tangle of dozens of rubber hoses, sensors, and solenoids, all working in a fragile harmony to adjust the fuel mixture. It was a vacuum computer, a brave attempt to replicate digital precision with analog air pressure. But it was a maintenance nightmare. A single crack in one of those 40-year-old hoses today can turn a reliable car into a baffling puzzle that is nearly impossible to diagnose. The ultimate nail in the coffin for the CVCC was the arrival of the three-way catalytic converter. Unlike the early catalysts that just cleaned up soot, the three-way catalyst could handle all three major pollutants at once. But there was a catch. It required the engine to run at a chemically perfect air-fuel ratio, not the lean burn ratio that the CVCC relied on. The chemistry simply didn't match. To meet this new reality, the industry, including Honda, shifted to digital electronic fuel injection. Computers replaced carburetors, and precise software replaced the clever third valve. By the late 1980s, the CVCC era had quietly ended, replaced by the modern standard of programmed fuel injection. Yet, even as the technology faded, its legacy remained untouchable. It was the bridge that carried the industry across its most difficult decade, proving that the combustion engine could indeed be tamed. Agility beats capital inertia. The clash between Soichiro Honda and General Motors wasn't just a business rivalry, it was a lesson in the nature of innovation. While Detroit tried to defend its past with lawyers and additives, Honda attacked the future with fundamental engineering. This story proves that intellectual agility will always outmaneuver the sheer inertia of capital. Today, the spirit of that combustion trick is more alive than ever. If you look at the cutting edge of modern Formula One power units, you will find jet ignition systems, technology that uses small, rich mixture pre-chambers to ignite ultra-lean charges for maximum efficiency. It is the CVCC reborn at 200 miles per hour. In recognition of this timeless ingenuity, the CVCC was officially added to Japan's Mechanical Engineering Heritage List in 2007. Soichiro Honda proved that the laws of physics are indifferent to the size of your budget or the badge on your hood. Sometimes, the only way to beat a giant is to simply be smarter.